Hello, today I want to look at solving by graphing. And remember, let's discuss what solve by graphing means. It means my job is to solve, to get an answer. And the method that I'm going to use is graphing. So when I solve by graphing, I'm going to graph to get an answer. Now, when we solve by graphing, a couple things that we need to remember is that solutions of quadratic equations are called roots or zeros, or solutions. Roots, zeros, or solutions. All three of those words can be used to mean the same thing. So you may hear somebody ask you to find the roots of a quadratic function, or the zeros of a quadratic function, or the solutions of the quadratic function, and they're really asking for the same thing. And what that is they're simply asking for the x-intercepts when you graph the function. That's where solutions are. Now, a quadratic equation can have one real solution, two real solutions, or no real solution at all. Let's look at what those might look like. Keep in mind, if the solution is the x-intercept, and I graph a quadratic, and it looks something like this, the solution is where it crosses the x-axis. The solution is my x-intercepts. So it would be these 2 points here. So anytime the parabola crosses the x-axis twice, I have two solutions. Well, what might cause it to cross or to hit the x-axis only once if it's a parabola? Well, if it's a parabola, it might hit the x-axis only once. Let's try that again. If the point that comes down and hits the graph is the vertex. So if my vertex is my x-intercept, then my vertex is the one real solution that I have. Now, it is possible to also have no real solutions. And what that looks like graphically is I would have a quadratic or a parabola that when sketched never crosses the x-axis. We know this graph just keeps going up and up and up and up, and there's no point in time that it will cross the x-axis. So this would be a case where there'd be no solutions. Okay, so let's talk about how we go about finding the solutions using a graph. The first thing that we're going to do seems pretty obvious. We're going to graph it. If I'm going to try to find my answers using a graph, then I actually need to graph the parabola. And we're going to use those techniques that we found from our graphing sheet, whether it be standard form, vertex form, or intercept form. If needed, it is possible that when we graph our vertex and our next points, that we may need to continue the graph until we reach the x-axis, until it crosses the x-axis. So you may not have to find just next points, but you may need to find the next points and keep going. What I would like you to do is to both circle and write your solutions. It's a good idea to get in a habit to say, hey, look, I know where these solutions are in my graph, and I know what the solutions are when I write them out, what x equals. And it's not a bad idea to check your work. Let's say check work using factoring or another method. Let's look at a couple of examples. I'm going to start with this first one, that is y equals x squared plus 8x plus 15. What I notice is that this graph is in standard form. And one of the first things that I want to do in standard form is find my axis of symmetry. So I'm going to use the equation x equals negative b over 2a. So I get negative 8 over 2 times 1, or negative 4. So I'm just going to sketch in my axis of symmetry here. And remember, my vertex is always on the axis of symmetry. So to find my vertex, I know my vertex is an ordered pair where the x value is the same as the axis of symmetry. I just need to find the y value. And I'm going to do that by plugging in negative 4 into the equation. Y equals negative 4 squared plus 8 times negative 4 plus 15. So we get 16 minus 32 plus 15. So we get negative 16 plus 15, so y equals negative 1. So my vertex is negative 4, negative 1. Well, now I'm going to work on my next points, and whether I use the idea of the parent function or I substitute values in, I'm going to either choose negative 5 or negative 3 because they're closest to the axis of symmetry. So if I choose negative 3, it's a smaller negative number. Let's see what it looks like. Y equals, and I'm going to do the same thing, negative 3 squared plus 8 times negative 3 plus 15. 9 minus 24 plus 15 gives me negative 15 plus 15, which gives me 0. So my next point would be the ordered pair negative 3, 0. And then I mirror image it. And this is enough for us to graph right now because my whole job, this is graphed, but is to solve by graphing. I did the graphing part. Now I need to find my solutions based on the graph. Well, remember, my solutions are where the graph crosses the x-axis. And I can see my solutions here are the solutions x equals negative 5 and negative 3. Now I'm going to check my work using a different method. Watch this. Oops. Why does it do that? I'm going to check my work using factoring. If I asked you to solve by factoring, remember the first thing I need to do to solve by factoring is set it equal to 0. So 0 equals x squared plus 8x plus 15. And remember, the way I want to solve by factoring is I want to look for a greatest common factor first, if I have one. And there's not. So since this is a trinomial where a is 1, I'm going to use the x factor method. So I'm looking for two numbers that multiply to 15 that add to 8. And the numbers that multiply to positive 15 add to positive 8 would be positive 5, and positive 3. And so my factors would be x plus 5 and x plus 3. And this equals 0. And this is the zero product property that we've been talking about. This tells me that x plus 5 needs to equal 0 and x plus 3 needs to equal 0. So x equals negative 5 and x equals negative 3. The same things we got by graphing. So my solutions can be seen on my graph as my x-intercepts. So let's hit pause and try B. Hopefully you had a chance to try B. Again, this is in standard form. I'm going to start with my axis of symmetry. X equals the opposite of B over 2 times A. So we get x equals 1. So x equals 1 is my axis of symmetry. And then I am going to find my vertex. And my vertex has the x value of 1, and I need to find the y value. So remember order of operations on this. When I square the 1, the negative is not being squared. It's not in the parentheses. So when I do my order of operations, I'm going to get negative 1 plus 2 plus 3. So y equals positive 4. So my vertex is the ordered pair 1, 4. Now I know from my a value that this graph should be facing upside down. And so I'm going to work on some next points. I'm going to try 0 because 0 is just to the left of the axis of symmetry. So I could try 0 or I could try 2. And if I plug 0 in, 0 is the easiest one to do. We get 3. So I have the ordered pair 0, 3. Well, here's the problem. Is this enough to sketch a graph? Sure, I got a decent picture of what the graph looks like. But the problem is I don't know what my x-intercepts are, meaning I don't know what my solutions are. And my whole goal of this is to solve this equation to figure out what the solutions are or what my x-intercepts are. So I need to choose another set of next points. Now we already chose 0 and mirror imaged it over to 2, so I probably should now choose either negative 1 or positive 3. I'm going to choose positive 3. I like positive numbers. So I'm going to plug in positive 3 every place I have an x. And this gives me negative 9 plus 6 plus 3, which gives me 0. So I have the ordered pair 3, 0. 3, 0. So I'm going to graph 3, 0. And then I'm going to mirror image that. Well, look at that. Sketching 3, 0. And when I draw my graph in, we'll pretend that went through that point. When I draw my graph in, I now can see my x-intercepts, which means I now know what my solutions are. And my solutions are negative 1 and positive 3. All right, hit pause and try the last one. Hopefully you notice this last one is in the vertex form. I like the vertex form because it's very easy for me to see my vertex right away. I know my vertex of this parabola is 5, negative 2. Which tells me that my axis of symmetry, which is always the x value of the vertex, is x equals 5. So I'm going to go ahead and plot those. My axis of symmetry is x equals 5. My vertex is 5, negative 2. There it is. Now I need to either use my parent function or my next points to come up with where this graph is headed. And I see that my a is positive, so I know it should be facing up. So for my next points, what I might pick is positive 4. 4 minus 5 squared minus 2. Well, I get y equals 2 times negative 1 squared minus 2. Order of operations, I'm going to square. And then I'm going to get 2 minus 2, and I get 0. That's always a good sign. When y equals 0, so 4, 0 is 1 point, mirror image it, I get 6, 0. Whenever I get 0, whenever I solve and get 0, it means I found an x-intercept. I found a solution. I found a 0. That's why they're called zeros, because it equals 0. And then I can set this equal, or draw in my graph, sorry, not setting it equal. And now I know that this is x equals 4 and x equals 6 are my two solutions. And that is how we solve by graphing. It's how we use a graph to find the answers. Have a good day.